All right, here we have 3.3, the section on two really useful and important rules, the product and quotient rule. So we'll start with the product rule and then we'll take a look at the quotient rule. So for the product rule, whenever we want to take the derivative, so again, that's what this notation is here, the ddx. This stands for take the derivative of whatever is lying to the right of it. So this is saying take the derivative of this. And then we have a product of two functions, f times g. A lot of times I'll be saying things like the first and the second when I'm differentiating things. So it's useful to think of this as the first function and this as the second function. Some people, first-time learners of this, will get very hung up on the letters F and G. And while it's fine to think of it as F and G, don't get too stuck in that way, because if we take a look at functions that are maybe named differently, or we define a function in terms of other functions, if you're always trying to come back and force things to, if you keep forcing yourself to think in terms of F's and G's, then we could really, it could really be difficult for you when you're differentiating some functions. So a lot of times I'll say derivative of the first, so like right here, derivative of the first, leave the second alone, plus the first left alone times the derivative of the second. So I use this language first and second a lot. That way I avoid talking about what the actual arbitrary name of the function is. So first thing to point out here for the product rule is that the derivative of two functions multiplied together, so the derivative of f times g, is not equal to the product of their derivatives. That is not true. So that's an important thing to keep in mind, that this is not a product rule. This is, a lot of people want this to be true, first-time learners of calculus, but it is not true. So make sure you don't fall into that pitfall. The derivative of a product is you are just taking the derivative of one of the terms of a product while you multiply by all the others left alone. So here we're taking the product of two functions, so that's why we have two terms in this product. True, if you really wanted to, you could think of differentiating maybe a product of, let's say, three things, f, g, h, in which case the derivative of this product, this threefold product, you would really just want to differentiate one of the three and then multiply by the remaining two left alone, so not differentiated, just leave them as is. Plus, well, we did the first, so this time let's differentiate the second, and then we'll leave the first and the third functions, f and h, alone. Lastly, we have to take care of h, so we'll leave f and g, the first two functions, alone, and we'll differentiate the third one, h. So really, at any given time, you're just differentiating by one of the terms of a product, leaving all others alone. So is it useful to think of this as a product rule? Sure. It's perfectly fine, but more often than not, you shouldn't really ever need to explicitly think about this. So I'll just leave that there in the video, but don't get too hung up on that. So let's go ahead and take a look at example 1 here. So for part A, and again, this is where it can get kind of messy if you start thinking of this as f and this is g, because this whole thing we're calling f. So if you get too stuck in your ways of literally thinking of this as f, then it can lead to confusion in some circumstances. So f prime, I am referring to the actual function. So the product rule up here says we're going to differentiate one, leave the other alone, and then add to that the opposite. So the derivative of x squared is 2x times e to the x left alone, plus we're going to leave x squared alone this time, and then we'll differentiate e to the x. But now remember that e to the x is its own derivative, so it just so happens that when you're working with e to the x, it can be a little bit tricky, because just by looking at it, you can't tell whether or not you differentiated it. The reason we can tell that it was differentiated here is in the context of a product rule. We can see that here the x squared was differentiated to yield 2x, or over here the x squared remained the same, so that means this must have been the derivative. But does it actually matter here if we know that this was differentiated or not? Not really. But just keep that in mind. So for part B, we've got a function g. So let's go ahead and say the derivative of g prime of x. We'll take the derivative of this first expression, which will just be 2 times e times x. So again, this is not e to the x squared. This x squared is just a multiple. And e, although a strange number, it is just a decimal. So the derivative of the first is 2ex times the second function left alone plus the first function left alone times the derivative of the second, which is 2x. Now in this class, when you're doing your work and when you're even entering stuff in on web work, you do not need to simplify this. Just leave it like this. There will be lots of times in the class where it will be useful to simplify, and the general rule of thumb is that if this is your final answer, you don't need to really go crazy simplifying it. If, maybe for instance, like in a later section, we're going to learn about what the second derivative means, if we were going to take the derivative of this, it might be useful to simplify it before we begin differentiating a second time. So if it's your final answer, for 99% of the time, your final answer you can leave unsimplified. But if you're not yet finished with that, you're going to use that answer to then go on and do something else, maybe a part B in a problem or something, then you're going to want to go ahead and simplify that as much as possible. Honestly, you're just going to make your life easier for yourself. So, part C, f prime of x, the derivative. Here, we see that we have that sort of triple product rule that we mentioned right up here. So we can use that if we want to. So the one way we can do it is by using this triple product rule, which maybe I'll do that triple product rule in red here, to match it with the red triple product rule up top. So this would be derivative of the first, leave the other two left alone, plus leave the first alone, differentiate the second, which is just the derivative of x plus 3 is 1, times the third, plus the first two left alone, x plus 3, times the derivative of the last one, which is 2x. So that works out well. Another way we could do this one, however, is to perhaps think of these two as 1. So if we do that, so if we think of as one term, then this derivative would look like the following. We'd have something like, so how about we just write it like this? We'll have the derivative of this first term times the second function left alone plus the first term left alone times the derivative of the second, which is 2x. So all this little ddx did was it just said, okay, this is a lot to do all at once, and one big step to write that all down would have been a lot. So here, when we take the derivative of this more complicated term, we can just put it on hold and say, hey, we'll do that in the next step. So in the next step, we can now unravel this more, and what do we get here? We have the derivative of we have a smaller, regular twofold product. So this would be derivative of the first times the second left alone, plus the first left alone, times the derivative of the second, which is 1, and then we have what we had from the previous step. Just copy-paste it. And you can see that if you go ahead and take this x squared minus 5 term, and we distribute it in through here, we will get these first two terms that we did with the triple product rule. So no matter how you want to go about it, whatever's easier for you, go for it. All right, and lastly, for this first example, the example for product rules, part D, f prime of x, this is going to be, again, a triple product rule. So what I'm going to go ahead and do here, based on how we go about teaching this M171 course, I want to actually edit this example, and because we haven't learned technically how to handle things like those two yet. So what I'm going to go ahead and do here is I'm going to just delete this and make this an e to the 4x really quickly. Okay. So now, if you're watching these videos in order, we don't know anything about this chain rule, which will be in a soon to come out video. So for now, what we'll do is the only way to differentiate these two terms is by first combining them. So we can use laws of exponents to say that e to the negative 3x times e to the positive 4x is equal to the we add our exponents. So if we add them, we'll just get x. So this would simplify into e to the x, x to the 7th. Sometimes it is good to simplify before you differentiate. So here we can get derivative of the first times the second left alone plus the first left alone times the derivative of the second. And there we have it.